A turbocharger provides an effective solution to one of the challenges facing many engine makers: how to breathe more air into the combustion chamber and do it efficiently. Here's how a turbocharger works. To get more air into the engine, a turbocharging system starts with an engine's exhaust gas, power that is essentially wasted in non-turbo engines. This exhaust gas is channeled to the turbo, where it spins a turbine wheel. This highly engineered wheel spins quite fast, reaching speeds of up to 280,000 RPM. On the other side of the turbine wheel, connected by a shaft, is a compressor wheel. These two wheels turn together, and the rapid spinning allows the compressor to suck in large amounts of ambient air and compress it. As a result, the air is very dense and has a higher temperature. This air then passes through a charge air cooler, where it is cooled and gains an even higher density prior to entering the engine. Once in the engine, the compressed air allows the engine to efficiently burn more fuel, making for extremely efficient engine operation. With better combustion, engine makers no longer have to resort to building bigger engines to get more power. Instead, they can use smaller, more fuel-efficient boosted engines that match the power of the larger engine, while consuming up to 40% less fuel and emitting significantly less CO2, making turbocharging a technology that's perfectly in tune with the needs of the 21st century.